Let's learn how to count protons, electrons, and neutrons. But before we do that, let's talk a little bit about the atom. Now, the atom is the smallest unit of matter. It's the basic unit of a chemical element. So the smallest unit of matter. Everything around us is made of atoms. The chair you're sitting in, the air you're breathing, the computer that you're using to watch this video is all made of atoms. The difference between those substances is how many protons, electrons, and neutrons that atom has. And that gives it different chemical properties. So an atom is made of protons, electrons, and neutrons. These are very small particles, very small particles. Protons are a positively charged particle. Electrons are negatively charged. And neutrons are neutral. They don't have a charge. Now your protons and your neutrons are found in the nucleus of an atom. So they're found in the middle. They are found in the nucleus. They're together. So the protons and the neutrons are together in the center of the atom. They form the nucleus. The electrons orbit on the outside of the nucleus. They are around the nucleus at a distance, and they orbit around. So if I were to attempt to draw just a simple atom, just a 2D atom, in the center I would put some protons. For this one I'll do four protons. And these aren't to any scale, they're just random sized. To go along with those 4 protons would be 4 neutrons. Then my electrons, that'd be on the outside of the nucleus, not near as big as the protons and the neutrons. And in this particular case, we would have 4 electrons as well, since it's just a neutral atom. Neutral meaning it has no overall net charge. The positive charge is balanced by the negative charge. So that would be our basic atom. In this case, 4 protons, 4 electrons, and 4 neutrons. And since it has 4 protons, this particular element would be beryllium. So counting protons, electrons, and neutrons of an atom is pretty simple. But unless you've got the periodic table memorized, it will help to have a periodic table. So let's take a look at a periodic table real quick. This is a very basic periodic table. You have an atomic number and atomic mass number. So our atomic number on this periodic table is going to be the whole number. The atomic number tells you the number of protons. This second number, the one with the decimal, is the atomic mass number. The one with the decimal is the atomic mass number. And on this periodic table, it's the bottom one. So this atomic mass number tells me the number of protons and the neutrons of an atom. So if I want to know how many protons an atom has, all I have to do is look at the atomic number, and it tells me exactly how many protons that element has. Neutral atoms, or ground state atoms, have no charge. That means the positive charge is equal to the negative charge. That means the number of protons is equal to the number of electrons in a neutral atom. So if I was looking at helium here and I had 2 protons, that also means I have 2 electrons. In a neutral atom, the number of protons and electrons are the same. This can change though later on. Those are called ions, but we'll get to that in a little bit. But regular atom, just a normal regular atom, or a neutral one, protons and electrons are the same. Now to get neutrons, you need the atomic mass number. So the atomic mass number was the protons and the neutrons. So if you want to know how many neutrons an atom has, you subtract the protons. So this helium here has an atomic mass number of 4.0. So if I want to know how many neutrons it has, I do 4.0 minus my 2 protons, and that says 4 minus 2 is 2, and that is 2 neutrons. So if you need a formula for that by chance, neutrons equals the atomic mass number, which is the decimal number, minus the atomic number, which is the whole number. And that'll tell you how many neutrons there are for a given atom. Let's look at the protons, electrons, and neutrons of a couple of elements here. I'll just write down some random elements and we'll solve for protons, electrons, and neutrons. Alright, for the first one, we got hydrogen. So again, you might want a periodic table if you don't know it off the top of your head. So I'm looking at hydrogen. Hydrogen has atomic number of 1, atomic mass number of 1.01. So protons, electrons, and neutrons. So we said the atomic number was 1, atomic mass number is 1.01. So protons, I can get that information from the atomic mass number, the whole number. So in this case it's 1, so that means hydrogen has 1 proton. Now since this is a neutral atom, the number of electrons will equal the number of protons. So if I got 1 proton, I have 1 electron. Now to get neutrons, I do the atomic mass number, which is the decimal number, minus the atomic number. So 1.01 minus 1 is 0.01, which is basically 0. So this one is 0. Let's do sodium. So protons, electrons, and neutrons. Let's look at our periodic table. So sodium has 11 for its atomic number, 22.99 for its atomic mass number. I'm going to round that to 23. So 11 and 23. So I got 11 and 23 for the atomic mass number. So 11 for atomic number, 23 for the atomic mass number. So for protons, we look at the atomic number. Atomic number is 11, so it has 11 protons. In a neutral atom, if it has 11 protons, it has 11 electrons. To get neutrons, we do the atomic mass number minus the atomic number. 23 minus 11 is 12, so this has 12 neutrons. Next we got sulfur. Sulfur has atomic number of 16, atomic mass number of 32. So protons, electrons, and neutrons. So the number of protons is 16. It's a neutral element, so electrons are also 16. Neutrons is 32 minus 16, which gives me 16. Let's do the next one, oxygen. Oxygen is 8, has atomic mass number of 16.0. Let's do protons, electrons, and neutrons. Atomic number is 8, that means 8 protons. If I got 8 protons in a neutral atom, I have 8 electrons. My neutrons are 16 for the mass number, minus 8 for the atomic number. 16 minus 8 is 8, so I got 8 neutrons. Looking at chlorine. Chlorine is 17, has an atomic mass number of 35.45. So protons, electrons, and neutrons. Atomic number 17, that means 17 protons. If I got 17 protons, I have 17 electrons in a neutral atom. And my neutrons is 35.45 minus 17, which gives me 18.45. I'm going to round that to just 18. And lastly, we got helium. Helium has atomic number of 2, and it's 4.0 for the mass number. Protons, electrons, and neutrons. Atomic number 2 means 2 protons. If I got 2 protons in a neutral atom, I have 2 electrons in that same atom. And neutrons is the mass number minus the atomic number. 4.0 minus 2 is 2. So I got 2 neutrons. So far, pretty simple. But as I said earlier, the number of electrons can change, and that's called an ion. An ion is when your atom changes its number of electrons. So there's a change in the number of electrons for an atom. So change in the number of electrons for an atom. The number of electrons can go up or it can go down. So if the number of electrons goes up and becomes more negative, that's called an anion. An anion gains electrons, becomes more negative. Becomes more negative. A cation loses electrons to become more positive. So anion gains, cation loses, but both are an ion. And both represent a change in the number of electrons. And changing those electrons can have different effects that we'll talk about later on. So when you have atoms that have a change in the number of electrons, you're going to indicate it with a plus or a minus sign in the top right corner, a superscript. So the chlorine ion would be Cl minus because it would gain 1 electron. Magnesium, for example, it could lose 2 electrons, so it would be a 2 plus in the top right corner. Oxygen could gain 2 electrons, so it would be 2 minus. And sodium could lose 1 electron, so it would be a plus sign in the top right corner. Let's count the protons, electrons, and neutrons of these. It's really no different from the neutral atoms except for the change in electrons. So chlorine, as we said earlier, has 17 protons and has a mass number of 35.45. So the protons are still 17. So if the protons are 17, that means the electrons are normally 17 in a ground state or in a neutral state. But we have gained 1. We've gained 1. So that means 17 plus 1, we now have 18 total electrons since we gained that 1. And neutrons are still the same, so it's going to be 35 minus 17. It gives me 18. Let's look at magnesium. I got protons, electrons, and neutrons. For magnesium, atomic number is 12. Atomic mass number is 24.31. So protons are 12 since the atomic number is 12. So that means that electrons are normally 12. But we've lost 2. Remember, a plus sign means you lost. A minus sign means you gain. So I've lost 2 electrons. So I subtract 2 from that 12, and now I have 10 electrons. And then to do neutrons, we do 24.31 minus 12 gives me 12.31, which I'm going to round to 12. Alright, now we got oxygen. So oxygen has atomic number of 8, atomic mass number of 16.0. So the number of protons is, of course, 8. That means its electrons are normally 8. But in this case, we've gained 2. So I add 2 to my electrons. 8 plus 2 is 10. So I got 10 total electrons now. And then for my neutrons, I do 16 minus 8 is 8. And the last one here, I got sodium. So protons, electrons, and neutrons. So sodium has an atomic number of 11. Its atomic mass number is 22.99. Since its atomic number is 11, it has 11 protons. If it has 11 protons, it has 11 electrons. But in this case, we have lost 1 electron, so I subtract 1. So it has now 10 electrons. And then for the neutrons, I do 23 minus 11, which gives me 12 neutrons. So ions isn't much different. You just got to remember to subtract or add correctly. If it's an ion, you're going to change your number of electrons. You got 2 types of ions, anion and cation. Anion gains electrons, becomes more negative. So that means you're going to add electrons. And it's going to be represented by a negative sign. Cations, you lose electrons, becomes more positive. So when you do cations, you're going to subtract electrons. And it's going to have a plus sign. So your chlorine and your oxygen here, those are anions. They're represented with that negative sign right there. They have a negative sign. Magnesium and sodium are cations, and they're represented with a plus sign. So plus signs you subtract, minus signs you add. Don't let that get you confused in the long run. So I hope this video helps. And as always, good luck on your tests.